Alright, welcome back guys. Today we will discuss this question. Okay, that we have given a zero index array called nums consist of n positive integers. Right. So in this array nums is called the alternating if it will satisfy these two conditions, right? You can see here nums of I minus 2 is equal to nums of I, right? It must be like this should satisfy this rule when like I is greater than or equal to 2 and less than n minus 1, right? And this was the first condition. Next condition it should satisfy is nums of I minus 1 is not equal to nums I, right? Where I is less than equal to greater than equal to 1 and less than equal to n minus 1, right? So like the second previous element must be equal to the ith index and the adjacent element must not be equal to that, right? This is called the true alternating array, right? So in one operation what we can do, we can choose an index I and change the element at that index into any positive integer, right? Then we have to return the minimum number of operations required to make the array alternative. So let's take this example 3 1 3 2 4 3, right? So here it is the example 3 1 3 2 4 3, right? What are the indexes here? This is 0. Let me change the color. This is 0 index, 1 2 3 4 5, right? So what are the, so this must be, let's say I am here, this must be equal to this, right? And this must be equal to this, and that's it. And next thing we should satisfy that 1 should be equal to this and this should be equal to this, right? So do you see any pattern, guys? Do you see any pattern? I see some pattern like 0 then 2 then 4 then 6 then 8 then 10, right? So all even indexes must be equal, right guys? All even indexes must be equal. And similarly, if I say this here is 1 then 3 index then 5 then 7 then 9, right? So for this index, what is I minus 2? 1. For this index, what is I minus 2? This. So all odd indexes must be equal, right? So we have two things. All the even indexes must be equal, all the odd indexes must be equal. So let's try check like what is the relationship between odd and even, right? So let's say we are here, this is even index. What is the relationship with this and this, right? So relationship with of this, so this element must not be equal to this, and this element must not be equal to this. So adjacent odd and even must not be equal, right? But what if they are equal? What if they are equal? Let's say, let's take some example, right? So okay, forget that. Let's stay to this first, then we will tackle that also, right? Let's take this example. We can change any element, right, to anything. So here in the even index 0, 2 and 4, we have 3, we have 3, we have 4, So 3 is 2 times, 4 is 1 time. This is for even index. What is for odd index? We have 1 time. We have 2, 1 time. And we have 3, 1 time. Right? So you see, at the even indexes, we should not change these 3 because we want minimum number of operations to change, right? So we can keep 3. We can change 4 to 3, 4 to or 3, right? So one operation is this, right? This becomes 3 here. And for odd indexes, they also should be equal, right? What we can do, we have 1, we have 2, we have 3. We can do anything, right? For this, what we can do, let's take 1, let's take 3, right? If I make all the elements of this 3, then this will be equal to this, right? This is not valid. Okay, this is not valid in this case. So what I can do is here I will not do 3. What I will do, I will do 2. So I will make all the other elements 2 here. No, let's change the color first. Let's take this 2 here, and I will make this is already 2. I will make this as well 2. Now you see what array will become 3, 2, 3, 2, 3, 2. This is the true alternating array, guys, right? So how many operations we needed? Was 3 operations, 1, 2 and 3. Minimum operation we will need, right? And this is minimum because let's say if I choose to change this to 4, so I will need 2 here and 2 from here. I will need 4 operations. So I have to get the maximum frequency, like preserve the maximum frequency element, right? So 3 was the maximum frequency element in the even indexes. This is this was the same. We will not talk about this for now, but yes, right, that is it. And right, so let's take another example. Let's say some example is this: all the elements are same, right? So 0, 1, 2, 3, 4 and 5 here, right? Now what I can do is 0, 1, 2, 3, 4, 5, all the even indexes are same, right? So 3 frequency is 3, and if the even, and 3 frequency is also 3 as odd. So maximum frequency element in even is 3 and maximum frequency element is odd is 3. So I can either keep this or I can keep this, because if I keep both, then it will be same, then adjacent element will also be equal, which is the false condition, right? Second condition, it will violate the second condition here. So I have to downgrade one thing. Either I have to downgrade this, either I have to downgrade this. Whichever gives me, let's say it was odd index is, it is 1. So 3 is 2 and 1 is 1, right? So this is giving me precision of 3. This is giving me precision of 3 as 2, right? So what I will do, I will downgrade this, right? I will keep this. So I will move this. So here I don't have to change anything. Here I have to change only 2 elements, 2, 1 at odd indexes, right? So minimum operation I require is 2, right? But if I changes this, right, like let's say this is 1 and 0 is 1 time, let's say. So I have to change 0 to 3 times here, and this is also 1, I have to 3 times, 1 time. So 3 plus 1 is equal to 4 times I have to minimum operations, which is not minimum, right? So that is it. Like what I have to do, I have to take maximum of what the max frequency of even, and second max frequency. Oh wait, let me write the code, then you will understand. Okay. All right. So first of all, what is the number of elements in here? Nonce dot size equal to 0, right? If n is less than or equal to 1, then I have to return 0 occasions because it's already alternating, right? Next thing is I need to take a map, because for like storing the frequency of maximum even indexes and the odd index elements, right? So I can take an odd the map, right? I can say even map comma odd map, right? And what I can do in this map is I can fulfill these like 4 and 0 I less than n, right? Plus if I modulo 2 equal to 0, if it is a like a even index, right? So what I will do is I will go in the even map, and what is the element of at nums I, right? I will increase the frequency of it, right? Else if it is not the even index, what I will do is I will take odd map and nums I, right? Plus, right guys? And I need like top two most frequent elements from the both the maps, because if they are like equal, makes top element of odd map is equal to the top element of even map, then I cannot like keep the both, right? I have to like degrade the one to the second top element of either odd or either even, right? So I need to take top two elements, right? Okay, so what I can do is using my pair equal to pair and print. So I will not use this again and again, right? Alright, so this will be the pair. So I need to top two pairs, right, in the return. So auto top two pairs, right, is equal to, I can define a custom function here. It will take some map, unordered map, and print, right, whatever the map is. In this map I need to take the elements, right? So here I can traverse the map, right? So I need top two elements, right? So let's say top 1 is equal to okay, my pair top 1 is equal to this, what initially it's 0 with 0, right? Because let's say all elements are 0, right? So I need to degrade to 0 at least, right? All elements are like equal quantity. Let's say for odd it is 3 times 3, and for even also it's 3 times 3. And if I downgrade this, I need to go to something, right? 0 0 like this. So I can pick 0 here. So this is like this, okay? Downgrade 0 0, and my pair top 2, right, is equal to 0 comma 0. Okay, so I can traverse this for because it's all pairs, right? My pair in my pair is P in map, right? Okay, I have pair. So if frequency, okay, what I can do, I have value and I have frequency. I have two things, guys, right? So auto value comma frequency in map, whatever I have, right? And also I can look like this, my pair also like this, right? I can do this, and so if right, frequency, whatever I get, frequency is greater than top one element of my top one dot second, right? If it is greater than this, then what I will do is top one is equal to this value comma frequency, right here. And what if it is not like this, right? And what I can do is top 2 is equal to top 1, right? I will assign this. If it is not like this, it is not great. Else what I can do is I will check for top 2, right? So if frequency is greater than top 2 dot second, right? Then in that case top 2 is equal to value comma frequency, whatever it is. But if it is not like this, then I will like keep this as it is, like it is not even greater than top 2, then I will not consider that, right? Okay, then after that what I can do is I can return make pair, right? Right, return make pair of top 1 comma top 2. So these are two pairs I am returning as the top 2, right? Okay, then what I can do is I will check the top 2 of the even and odd map, right? So auto top even, right, equal to what, top 2, I can even map, and auto top odd, top 2 elements of odd map, right here. Now what I can do, I have this map, like top even, I have top 2 map of even map and top 2 pairs of odd map, right? Not map, the pairs, right? Top 2 pairs of from both. All right, now if it is like both are same, then I have like 0 0 as default, right guys? So that's not a problem at all. Now what I can do is if they are like if okay, if both the top elements of both are not equal, of odd, even, and right, top of even, right, dot first dot second is not equal to top odd dot first dot second, right? If they are not equal, then what I can do is right, if they are not equal, then how many element I can save, right? How many elements I can save? So int saved is equal to here this that top even dot okay, this is first elements, first okay, dot second plus top or dot second, right? And I can return the n minus saved elements, right? But if they are equal, guys, if they are equal, right, what I can do, I have two cases, right? Either I will pick the top of even and second top of odd, or I can pick the second top of odd, no, first top of odd and second top of even. So whichever gives me the maximum saved numbers, I will keep that, right? So what I will do is integer, right? Top even, let's say, is equal to top even, no, what, top even what, oh, it's not like this. So t even, let's say t even is equal to top even dot first dot second plus top odd, right, dot second dot second, right? And then if enter top odd is equal to top odd dot first dot second plus top even dot second here, right? So int max top is equal to, no, max saved into max of t even comma t odd, and I will return n minus max saved elements, whoever saved the max elements, right? That's it. And at the end I can return 0, right? Let's see what is the oh, I have assigned also, wow. Alright. Okay, I can do auto here, whatever it is, right? Where is it? Okay, second dot second I need. Okay. Okay, one case is good, then other case is bad. Why it is? It's in this case output is 1 and right. What is the error we are doing here, guys? Max even t odd top even first dot second, top odd second second. Okay, top odd first dot second second, that is correct. Top even first second, top odd second second. What? First second, guys. It is first. Now it's expected to. Okay, I will see that top or first second. First second. Okay. Top frequency is top 1, top I will give assigning is top 2 is top 1. Okay, if frequency top 2 dot second, correct. I think I have done things correctly, but what is the problem here? N is less than equal to or equal to 1. No, that's not the case actually here, because what is the problem here, guys? Top 1. Okay, let's do this. Because I was doing this thing, top 2 was here. I have to assign top 1 for first to top 2, then top 1 will modify it, right? That's the case. You see, guys, we beat 80% of the runtime and 85% is the memory. So I think it's a very optimal solution. Thank you so much, guys, for watching, and we will meet you next lecture. Thank you so much.